Okay, today we are going to solve one of other question GATE 2020, and this came in GATE 2020. So today we are going to solve this question. So here it is 9 bbn and they have given hydrogen peroxide and sodium hydroxide. So this is basically a hydroboration and oxidation reaction. So before just going on to directly to this 9 bbn, I'll just give you what actually is hydroboration and oxidation. Take any simple alkene, think of any simple alkene, and B2H6, that is boron, or you can just write it as BH3 because it exists as a dimer, but here it is like this. So there will be a partially positive charge and a minus charge here. So it will be like this. So here it will be BH2 and H. So this is a hydroborated product. Now the next step is, so what they took is they took H2O2 in the presence of sodium hydroxide solution. So this OH minus will take a proton to generate this species HO minus. And now we have B, H and H with a partially positive charge and O, H, which will interact with this to give H. Now what will happen is this CB bond, it will migrate here, resulting in the removal of this OH species. So which is B, sorry, so which is O, B, H2 and here it is OH minus. So OH minus will again take this BH2 and this O will take this, resulting in the formation of BH2OH species and O minus, which will H3O plus, that is hydrolysis, rise to OH. So this is the resulting in the formation of oxidation of alkenes to alcohols. So this is a hydroboration and oxidation, and this is the final product. And another thing is 9 bbn. And the reagent that is used is 9 bbn. So 9 bbn is basically 9 bora bicyclo 3,3,1 nonen. So this also it is used as in a hydroboration. It is a reagent. It is a bulky reagent. So helps in the formation of selective products. It is helps in the formation of selective products. So how do we prepare 9 bbn? You took 1 octadiene, 1,5-octadiene in the presence of boron dimer BH3. It will give you 9 bbn, or you can write it like this. in simple general formula, which is 9 ppm. So when moving on to the question, I think by now we can get an idea about what is hydroboration and the role of 9 ppm, and we are adding only one equivalent of 9 ppm. So that means it will only reduce one double bond of only one double bond. So it will convert only one double bond. So let's take our reaction, which is this, and the planes are also given, I think. So this is like this. Now, so when you add 9 ppm, the main question is which side it will reduce. Will it reduce this side, A side, or will it this reduce B side? But both, since both are symmetrical, that is this side or this side, and if any side it reduces, it will be the same. So it can reduce either this side or this side. So let's think we are reducing this side and keeping this one. And since there is only one equivalent, it will reduce only one double bond. Now another is how in to which side this B boron will add. So what you will do is, since there is a C double bond, the electrons will shift towards this side, developing in the a negative, partially negative charge and a partially positive charge here. So the positive species, that is a boron species, will interact with the negative side, and the H minus will interact with the positive side, like this. So it is C double bond O, OET, which is BH, like this. Sorry, not BH. So boron like this, and there is an H. So now there is an oxidation, same O minus, O and H, resulting in the formation of an alcohol. So this is our first step product. Think it of it as 1. So in all these things, so we can say that we can exclude C and D. So we can say that either A can be our correct answer or either B can be our correct answer. So the next step is, so this is the product P. So from P to Q, there are a set of reagents. The first one is methane sulfonyl chloride in the presence of triethylamine. So methane sulfonyl chloride is basically CH3S double bond O Cl. So in the presence of triethylamine, since we all know triethylamine is a base, this will take out the protons. So it will is CH2 minus S double bond O Cl. So the negative charge, the electron will shift to this side and remove, resulting in the formation of an chloride, which will form as CH2 double bond S double bond O, which is a sulfate. Now whenever an alcohol interacts, that is ROH, it will attack on this side. So CH2 double bond S O minus double bond O positive charge H, which is R. CH3 S double bond O, which is O R. So basically the alcohol is protected and this O misylate. So we can write it as ROMS. In the same way we can say that OMS, right? So after that another set of reagent is sodium hydroxide. So there is an ester and there is an sodium hydroxide. So what will happen? Hydrolysis. So hydrolysis of esters to carboxylic acids. So here C double bond O OH and there is an OMS. So this lone pair of oxygen will interact with here resulting in the leaving since OMS is a good leaving group. So since this side is an above the plane, the OH will attack from the behind the plane, that is the back side. So the product is C double bond O. This clear. After that, what they did was hydrogenation. Simple hydrogen in the presence of rhodium hydrogenation. So the double bond will reduce, resulting in the formation of right. So this is our product Q. So in this the so the second one B is our correct answer.